Hi, welcome to this presentation on the encryption options that are present in IBM Spectrum Protect. I'll be going over the different areas where encryption is possible with Spectrum Protect, and this includes on the Spectrum Protect server, Spectrum Protect client, with the devices, in the transportation SSL layer, and with Espera. So we'll start off on the Spectrum Protect server. And when we introduced the container storage pools back in version 7.1.3, one of the things that the container storage pools support is deduplication, compression, and encryption. Now, encryption is currently supported with just cloud containers as of version 8.1.1. And so this would be either on-premise or off-premise cloud containers. And the order in which the processing takes place is that the deduplication takes place inline as the data is being written to these containers, and then optionally compression and encryption would occur. So the order is deduplication, and then optionally compression, and optionally encryption. So the encryption is done so that it is a set it and forget it type of encryption. It requires minimal user interaction. The encryption for off-premise clouds, when you set that up, is by default, and then it's optional for your on-premise cloud pools. Now, encryption can be enabled through the command line if you're not doing it through the operations center, and that would be either with your define or your update storage pool commands, and you would simply say encrypt equals yes or encrypt equals no. Once encryption is enabled, then all of the new data that's being written into that container will be encrypted. So any of the existing data that's already been written out there prior to you turning on encryption will not be affected. It will remain unencrypted. If you do turn on encryption for your cloud pools, the replication cannot currently occur between two Spectrum Protect servers with encryption. So prior to doing the replication, we will decrypt that data and then send it over just as deduped and compressed data. To compensate for that, you could utilize the secure socket layers between the source and target Spectrum Protect servers. We do support both server-side encryption and client-side encryption, and this chart here lays out the differences between the two types of encryption. First of all, server-side encryption is done at the storage pool level versus the client encryption, which is at the object level, done through the include encryption and encryption type options in your options field. On the Spectrum Protect server, it manages its encryption keys versus on the client side, it's optionally managed in the tsm.pw file on a key ring. On the server side, we use AES encryption with minimal key length of 256 versus on the client where we've supported everything from DES56 up to AES 256. The server also signs the encrypted data in order to be able to detect any tampering or corruption on that encrypted object, versus the client, which does not do this extra step. And finally, the data that's encrypted on the server side can be deduplicated because remember, we do deduplication, then compression, then encryption, versus if you encrypt on the client side, neither the client or the server can dedupe it. And we'll talk a little bit more about that in a minute. When you go through the Operations Center wizard to set up a container, it will prompt you if it's a cloud storage pool to turn on the encryption. It will also make sure that you have the necessary database recovery pieces set up, and that's to protect the encryption keys that are being created for the different objects. And if you don't have those protection of your Spectrum Protect database, then it would be impossible to restore any of the encrypted data in that container. To get into more details on that, when we are encrypting on the Spectrum Protect server side, we're managing at the dedupe chunk level. A unique random encryption key is being created for each chunk, and that's used to encrypt the data. We then have a master encryption key that is used to encrypt each chunk key. And the master encryption key is automatically generated when you either upgrade to 7.1.3 or above, or when you install a new Spectrum Protect server at 7.1.3 or above. This master encryption key is going to be stored outside of the database in the dsmserve.pwd file, and that's in your server instance directory. And it is encrypted using a key derived from your server password. So you do have to issue the set server password prior to turning on container storage pool encryption. And in order to utilize this, you have to have access, and it's usually instant user access to the Spectrum Protect server, or on Windows, you need to be a member of the administrators group. So in order to protect these encryption keys, remember, you've got to back up your Spectrum Protect database. So database backup has been enhanced to optionally back up the master encryption key. And the database backup is already regularly used to protect your server instance. In fact, everybody should be running those daily. And the backing up of the master encryption key is optional because a password has to be specified to protect the master encryption key. The storage pool encryption cannot be configured unless you've set it. And that's done with the set DB recovery, protect keys equals yes, password equals, and then the password text. And if there is a disaster and you have to restore your Spectrum Protect server, and that key will be recovered using the restore DB command. Server-side encryption does add some additional time to the overall backup times. So you'll see about on the order of 1 to 2% of the total time required to do the backups. The backups are being deduplicated and optionally compressed and encrypted and staged on a directory container storage pool. Once the network has bandwidth, we start pushing that data out to the cloud. So actually, the amount of extra time it takes to do the encryption is still going to be less than the amount of time it usually takes for the network to have enough bandwidth to write to the cloud. That was server-side encryption, which we now support on our off-premise and on-premise cloud containers. Now we're going to look at client-side encryption. If you decide to have the clients or API encrypt the files prior to sending them across the network to the Spectrum Protect server, it is the last step before that data is sent across the network. We can utilize the AES 256 or 128-bit encryption, and then older clients do support the 96-bit encryption. It is simple key management. It stores the key either in the Spectrum Protect client password file, or it can be sent to the Spectrum Protect database where we simply store the key in one of our fields, not in the same way that we store the keys for the server-side encryption. Encrypt this data on the client side and then back that data up or archive that data to either our legacy storage pools, which would be your files, your VTLs, your tapes, or you can back it up to the container storage pools. But if you encrypt the data prior to sending it to our containers, the containers will not even try and dedupe it. It'll recognize it as encrypted data and just write it out there undeduped. There is no extra charge for using either the client or the server-side encryption. If you do want to turn on client-side encryption, in the client's dsm.op file, you do need to specify include.encrypt, and if you want to exclude any files, the exclude.encrypt. You need to specify your encryption type, and then tell how you want to keep the encryption key. Do you want to save it? Do you want to be prompted for it? Or do you want to generate it? The save will have the encryption key password saved in the backup archive client password file, which is tsm.pwd on your Spectrum Protect client. And when you go to retrieve or restore a file, it will pull from this tsm.pw file for the keys to unencrypt it before it's written out to the location you want it restored to. If you want to be prompt for the encryption, then you need to remember that key. You yourself are going to be prompt, and you yourself will have to type it in for that restore. If you specify generate, then the encryption key password is going to be dynamically generated when the client begins a backup or archive. And that generated key is going to be used for any of the files that match that include.encrypt file and are not excluded. That key is going to be sent in an encrypted form over to the Spectrum Protect server, and we will then save it in the Spectrum Protect database as an inventory record associated with the file. That key password is then returned to the client if you are doing some type of restore or retrieve, and it's used to automatically decrypt that file. Client-side encryption can be used to encrypt files on the client before they're written out to either legacy storage pools, which once again would be like your file or your tape or your VTL pools. They can be written to the Spectrum Protect server and sent to a out-of-band dedupe storage pool. This is our older type of deduplication storage pools. Or the client-side encryption can be done, and then those files can be sent to the new inline dedupe container storage pools. So we're going to look at those three different options and how the client-side encryption, client-side compression, and client-side dedupe impact each other when they're written to these three different types of server storage pools. If it's simply going out to a legacy storage pool, then the client will simply encrypt it and the file is sent and written directly to that legacy storage pool. If it's written to an out-of-band dedupe storage pool, we will encrypt it, but we can't dedupe it, and that's the same with a container. So if you encrypt on the client side, it will not be deduped on the server side. Likewise, if the client side encryption is turned on and you try and turn on client-side dedupe, your client will only encrypt that file. It will not dedupe it and then encrypt it and then send it across. It will only encrypt it. So client-side encryption overwrites any type of dedupe. However, if you're using client-side compression, then the file will be encrypted and then it'll be compressed and then it'll be sent over to either the server legacy storage pool or to the out-of-band or inline dedupe container storage pools. In both of those cases, it will not be deduped. So moving on, when we look at the data protection pieces that work with Spectrum Protect, a lot of those utilize our API. And so I wanted to outline how this Spectrum Protect family of products are impacted by encryption. If you have Spectrum Protect for VE, then we do support SSL, and we do support writing that VE backups out to a server-side container pool, so the encryption can occur on the server side. However, client-side encryption for incremental forever backups is not supported for your Spectrum Protect for virtual environments. For your Spectrum Protect for databases, mail, SAP HANA, and so forth, the API does support turning on encryption, so those files will be encrypted prior to being sent to the Spectrum Protect server. We also support SSL, or if you simply want to back up those files and you want the Spectrum Protect server to do deduplication and encryption, that would be supported. Or you could utilize the encryption that's provided by the databases. The SQLs, Exchanges, DB2s, Oracles, and SAP HANAs all have encryption capability built in for the data that's stored within the DB. So if you turn that on, when the Spectrum Protect for data protection product goes and backs it up, we back up the data as encrypted data. That TDP data most likely will not be deduped by the Spectrum Protect server, but it will be stored in the encrypted format that it was originally written by that database program. If you're using either of our space management programs, the Spectrum Protect for space management on Unix, we use the same mechanism as the backup archive client for doing the client-side encryption. And if you're using Spectrum Protect HSM for Windows, that's simply considered API data, and you'd use the API options for the encryption. Back on the Spectrum Protect server, if you do have tape drives that support encryption, for some of those tape drives, we can actually utilize this application managed encryption. And if you look at this picture right here, the tape drives that support this application managed encryption allow programs like Spectrum Protect to actually generate and manage the encryption keys and policies. They also allow systems to do this type of encryption. This would be like device drivers or operating systems. Or they allow the library themselves to manage the encryption. And that's why you'll see for our IBM 3592, Generation 2, 3, 4, and 5, as well as our LTO, Generation 4, 5, 6, and 7, as well as the storage tech devices B, C, and D, when you're doing the define dev class, you can optionally set the drive encryption to either on, allow, external, or off. If it's on, then the Spectrum Protect server is going to be the key manager for the drive encryption. And this allows drive encryption for empty storage pool volumes only if the application method is enabled. If you take the default of allow, then Spectrum Protect does not manage the keys for drive encryption. However, the drive encryption for empty volumes is allowed if either the library or system method of encryption is enabled. If you specify external, then Spectrum Protect does not manage the keys for drive encryption. You would use this with an encryption methodology that's provided perhaps by another vendor or that uses the application method encryption enabled on the drive. And if you turn it off, then drive encryption is not allowed. And if you try and enable that, either the library or system method of encryption, the backups will fail. And if you enable the application method, then Spectrum Protect disables encryption and backups are attempted. Now for other devices, if it's a hardware or operating system disk encryption or disk that Spectrum Protect database or log or storage pools reside on, this is invisible to us. We don't test for it. It's transparent to Spectrum Protect. And there is possibly overhead for the IOs and read-writes compared to non-encrypting storage. It's up to the customer to determine whether or not it's suitable to their needs and the performance is what they're looking for. If you have a VTL that does encryption, then encryption is also outboard from the Spectrum Protect server, and it's done in the storage, transparent to Spectrum Protect yet again. Now, the suitability of utilizing VTL encryption, you got to take into consideration how is it performing, how does it scale, how are you going to manage it if there is a disaster recovery and we got to pull back data out of those storage pools, and different pieces like that, so that the customer has to look at the entire solution and see if VTL encryption is the right choice for storing Spectrum Protect data on. If the files that we're looking to protect are going to be encrypted by either the operating systems or device, then we have two options. We can either back those up in raw encrypted format, or we can decrypt them and then back them up. Specifically on the AIX JFS2 encrypted file system, there is the option of EFS decrypt that you can put in the dsym.op file, and that allows you to back up either in clear text or raw encrypted format. If you decide to do the encrypted raw format, then the data will not be decrypted. That is the default. With clear text, then the file is going to be decrypted by EFS as it is read by Spectrum Protect. And this is going to be useful if you want the Spectrum Protect encryption to be utilized or other hardware encryption like the tape drives. Or if you plan on keeping a long-term archive of that data and don't want to have to worry about keys. Now, the user who invokes a backup must be able to decrypt the data. They must have permissions to do that. And this is usually read access to the file. Okay, so we've talked about using encryption on the Spectrum Protect server, on the Spectrum Protect clients, and on devices. Now we're going to look at the communication methods and encrypting utilizing either SSL or TLS. SSL stands for Secure Socket Layer, and TLS is the follow-on to SSL, and it's known as Transport Layer Security. With the Spectrum Protect server, we can have secure communication between the server and the backup archive client, between the server and additional Spectrum Protect servers, between the server and the operations center. All of those you are able to turn on the SSL layer. All of this is documented in the Knowledge Center, but basically there's a couple steps there. If you have a version 7.x server or a server that was upgraded to version 8.1, then you do have to go into the dsym.serve op file and add in your SSL options. You need to make sure on the DSM server you've done the define server and the set SSL keyring password. And then you need to go in and set the default label with this gsk8 capi cmd command. Once you've set the default label, then you want to copy over the cert256.arm file to any of the clients or such that you want to communicate securely with. On the Spectrum Protect client itself, you'll add that cert file into the client directory, and then in the client's option file, you'll set SSL to yes, and you'll set the admin port and the SLTCP port to the same as you did on your Spectrum Protect server. You then have to create the cert database using the gsk8 commands, and add this cert256.arm certificate to that database. Now with the 8.1 and 8.1.1 new server installs, some of these steps have already been done for you. You no longer have to set the default label in the cert.kdb file, and some of the options are already set in the DSM-Serv option file. I do have a YouTube demo out there you can check out and see me installing the self-signed certificates on the Spectrum Protect server and client. Now, in addition to self-signed, we also support CA signed certificates, and if you want the process for that, once again, check out the Knowledge Center. Okay, up to this point, all of these encryption options have been included with Spectrum Protect. We do have a product you can buy to provide WAN optimization when you're replicating between two Spectrum Protect servers that are both X-Linux servers. And this is called Espera. Espera provides fast and secure protocol, FASP. And this is really great if you have a network that has high latency or that loses a lot of packets. Then Espera will build a more robust connection between your Spectrum Protect servers. FASP does provide SSL and AES 128 encryption when we are communicating between the two servers, and this is regardless if you have SSL or encryption enabled on your Spectrum Protect clients or servers. So when we look at Espera FASP being a fit, we're looking at connections between two X-Linux Spectrum Protect servers that have a latency of greater than or equal to 50 milliseconds and a packet loss greater than or equal to 0.5%. For those types of network, FASP will help to drastically improve your throughput. So in summary, Spectrum Protect supports both server-side, client-side, device, and communication encryption, giving customers the ability to choose the encryption solution that fits their needs best. Thank you.